I'd like to show you an example now of a molecular weight type problem. Now we know that molecular weight is going to be grams divided by moles. So it's the grams of the substance divided by the number of moles we have. And that's also expressed as G over N, where N is another symbol for moles. So we've got here grams. So what we need is moles. And we can get moles from this information by using PV equals nRT. Now the way I set this up is by showing the values of P, V, N, R, and T. We have a value of R, which I'm going to quote here. That would be given to us. And it's 0.08206 liters atmospheres per mole per Kelvin. And what that means is that any of these that we use have to have the same units so that they cancel to give us what we need. And the pressure here is 745 millimeters of mercury. I want to point out that in this instance it's not said that it's collected over water. That means that since there's no mention of being collected over water, we can assume that this is going to be the total pressure of the gas, and we don't have to subtract out the vapor pressure of the water. Had this been collected over water, we would have to look at the vapor pressure of water table and subtract out the vapor pressure of the water. The pressure, we have to get into atmospheres because we need this to match the unit of R, and we will do that by doing conversion, and it's 1 atmosphere over 760 millimeters of mercury. And that's going to come out to be 0.980 atmospheres. Now remember, we're doing this so that we can get some sort of match between these units. The volume is 270 mils, and we know that that needs to be converted into liters, so it matches this. And so it's times 1 liter over 1,000 mils. That's going to be 0.270 liters. N is what we're looking for. Temperature is 77.0 degrees Celsius. And we're going to add 273 to that to give us a Kelvin value, which is 350 Kelvin. Alright, so now we've got all the units matching the units bar. We can go ahead and do our conversion. We can see that we need N, so we're going to divide both sides by RT. So N equals PV over RT. And go ahead now and plug in my values. 0.980 atmospheres. And we've got a volume of 0.270 liters. Oops. Between 0.8206 liters atmospheres per mole per Kelvin. Times the temperature, 350 Kelvin. I want you to see here that the kelvins will cancel, the liters will cancel, and now the atmospheres will cancel as well. And all we're left with is going to be moles, and that's going to be 0.0092 0.21 moles. Next, we can figure out what the molecular weight is, since we've got the grams and we've got the moles now. So MW is going to equal the 1.484 grams, and we get that from the problem, divided by the number of moles we actually have. And that's going to come out to be 161 grams per mole.